Hello, everybody. My name is Sami. I'm a senior machine learning engineer working at a company named Jina AI. And today I will talk to you about modern type Python, and we will dive into a mature ecosystem from web development to machine learning. So let's get started. So just brief overview of what we will see today. We will start with an history of Python and type hints. And type, the history, and then we will dive into the ecosystem around this typed Python. And finally, we will finish with a look at the machine learning world and how this typed Python is applied in this machine learning world. And we will talk about this library, DocArray, and spoiler alert, I'm one of the maintainers of this library. Let's start. So is Python a type programming language? It's actually, yes, it is a type programming language, but it is a duck-typed programming language. Maybe not everybody know what duck typing means, and a duck typing is a kind of typing in programming language. And the idea of duck typing is in Python, when you define a function or a class or any variable, you don't have to precise the type. So duck typing is an opposite of static typing. So here, for example, you see this is a Python function, you define an addition, you just say that you want a variable x and y, and you do your addition, but you don't have to say, like, this can be anything, basically. Whereas if this is a Rust example, if you take a Rust or a C++ or a Java function, which is statically typed programming language, you have to define what your function is working on. And in Python function, everything can be passed to the function, whereas in static typing language, the function signature need to be respected when you pass your argument to a function. And the idea behind duck typing is to say that a function in Python will work if the object walk like a duck, talks like a duck, then it's a duck. It's like Python, we don't need it to actually be a duck to consider it as a duck. It just needs for it to walk and talk like a duck. It don't really care if it's really a duck or not. This actually maybe the best example is like, here you see that this is duck typing in this essence of duck typing. Here you plug a charger on an electric slot, but you don't care if this is a pig nose or an actual electricity slots. All you care is that these things are two holes. And this is Python. What's going to happen is Python will try to plug the electricity. And then if it fails, it fails. But for him, it looks like it will be working, so he will try. And let's say that in a more static programming language, like something will happen before, and you are like, wait, I cannot plug this electricity into a pig nose. A pig nose. It will actually, this error will be catched really before you actually try to plug it. But in Python, in duck typing language, this happens when you try things. But duck typing is one of the reasons of Python success. They have a lot of advantage. First, probably the most important one is it's simple and fast to write and to read the code. Like, you don't have to say each time you declare a function or a variable, you don't have to say what type it is. So it means that a function definition will have to be smaller in terms of characters that you have to type, because you don't have to add this extra information. It allows as well that you don't have to think too much about abstraction. You can just pick object and plug them together, kind of like if it was Lego. It makes Python a really great language for scripting. It's not too verbose, again, less character, basically. And this is one of the reasons of Python, especially in the data science world, where you just want to pick really big data table and do operation on it without necessarily thinking about defining the class and always running your code each time you do a small modification. But of course, there are some defaults, some cons as well. Probably the most important one is it's hard to maintain. Because you lose this information in the definition of the function and in your language, you don't exactly know what go into what. It's like basically this example, right? It's hard to maintain if you don't know if you plug your electricity into a pig nose or an electric spot. This will be hard to maintain. And another problem, which is quite an important problem, is error will be catched at runtime rather than compile time or like before you run your code. It means that Python, if something go wrong, it's after the function has been called and you try to plug your electricity charger into the wrong thing. It will not be catch before, even though technically you kind of like check your code and say, oh wait, this will never work because this is not an electricity plug. But in Python, you will have to wait at runtime to find this about this error. Okay, so first statement is Python is a doc-type language. But if we look at modern Python, what I call modern Python is code base that you can find in 2023 or 2022, you will see that it's actually full of type information, what we call type hint in the Python world. And it's kind of weird, right? Because I just say that it's one of the big success of Python is it not being a static type programming language, but a doc type typing one. For example, let's take a look at, this is from a screenshot of today of the README of FastAPI. FastAPI is one of the most known web framework in the Python world. And look at this. I mean, you see string, float, union. This is type information, right? When you define your function, it's the same. You have type information. But it's weird because I just say that Python is in its essence was not a static type programming language. We don't have all of these type things. So let's try to understand how did it happen and why those types are now part of the modern Python ecosystem. But first, let's say, before going to the history of what happened and how it happened, let's just explain why we have this type hint in Python and why it's actually useful. So typing in Python is the way to actually precise when you create a function that, for example, here you want your function to accept either string or int. But if you pass a float, it should not work. Or like at least you know it might not work. But here is the same. You can say that you expect this class. This is a way to you can express the return type of a function, saying your function will return a string. It means that when you work with this function, you don't have to check that the return statement will be something else. You know it should be a string. Like the developer of this function has told you, this is what should be the input, this is what should be the output. One of the really big advantages is it's really expressive. I mean, you can express what your function is actually doing, and someone can go read your code and understand it better than if it has to understand line by line what will be the return value or the return type. You can just look at the signature. It's actually it's easy to onboard people on code base when you are full of type hints. So let's say you are an open source contributor and you look at a project that you want to contribute with it, but at the beginning you will be, I mean, open source code base can be really big, really complex. And let's try you want to fix one ticket, for example, a small things like a small thing in a small function. And then you know already what will be the input of this function. It means that you don't have to go into the entire code base and look each time we call this function, what are the possible input for this function. So you can just, you will live in your small world when you know what is input, output, and you can sync with it and just work at this level. Type hint is still fully compatible with the duck typing. It means like when you use type hint, it doesn't mean that duck typing is not working. Actually, this is just hint. It means that it doesn't enforce anything. It's not enforced at runtime or it's not enforced at compile time. It's still as before. But if you don't want to put type hints, you don't put type it. It will still be compatible. It's still all same as before with Python. You can actually mix functions which have type hint and no type hint. One of the strongest points of type hint in Python is that IGE they love typing, and I really want to emphasize this point because for me it's one of the most important one. And when you are using a professional IGE like PyCharm or VS Code, you can see that it can help you to do a lot of things, refactoring, changing the signature of your function, and you can jump from part of your code to other part of your code, or you can highlight when you think that you are doing a mistake. Right, you're accessing an attribute which does not exist, or you try to call a function an attribute which is not supposed to be called. And this is only because if you add type hints, then the type checking system of your IGE can understand if things go wrong, because it can just check the type and say, oh, this is not going to work. Oh, yes, this is going to work. Another point, it make refactoring easier in general to have type hint because, well, if you change the signature of your function, you don't have to run the code to check that, oh, you forgot to cast a float somewhere in your code base. You just can write some static type analysis and it will tell you before running, this is it will tell you this will not work. I know because the type are not compatible. And again, it's easy. It will basically help you to find bug in your code without actually running. So let's say you want to do some machine learning or deep learning, and you have like a really long process, and you change the last part, which log your training loss, let's say, and this arrive at the very end of your training. Let's say that you did a mistake, and instead of printing a string, you print an object which cannot be printed. Then everything will fail, and you cannot print your log just because of this, and you have to wait 1 hour to actually see this error. Well, if you use type hints, basically you can catch this before, because when you will call print on this object, your static type analyzer will told you it's not going to work. I know because this object cannot be printed. And this is all about the type system in Python allow you to have all of this expressiveness. So let's take a look at the history and how this happened. How do we come from duck typing to type hints? Python, it's a old programming language, and it has been released in 1991 by this guy, Guido van Ramus. Yeah, I think he did it in a weekend project or 2 weeks holiday, something like this. 10 years later, Python 2.0, he's not one guy working on this anymore. He has a team, Python Lib team. And this time, we don't even talk about type hint at this time. This doesn't even exist in Python. It's still full duck typing. 2006, Python 3.0 development, still by the same team. And same, at this time, typing were not a thing. But what actually, so in Python 3.0 2006, Python was out for 15 years already. And Python has this docstring feature when you can basically put comments here, which will be saved into the function definition. And what people and what the Python developer realized, it's that people were using this docstring as a way to express type information about the variable. So basically, this was a very often used syntax in some Python code as well. You say that this x should be an int, this y should be an int, and the return will be an int. And this is kind of like already giving type information, right? But this is not part of the programming language. This is like a comments in a code base, right? But still, it shows that people wanted to have those things. And you even have some ecosystem of tools which were looking at this docstring and doing some things. So for example, IG, we were starting to inspect those value here and trying to do some type guessing and to do some static type checking, etc. But what it showed, at this time, people wanted a way to do type hinting. So in 2006, the first PEP about close to type hint arrived, and it's called function annotation. So function annotation is not yet type hint, but the idea is like you can transform this code in the left to this one in the right. So you can so what is annotation doing is it takes this information and put it here. And this is string. This is any object that you can put. This does not have to be a type, but this is kind of intended to be type. So what's actually happening in practice is like with this new PEP in this new syntax, this value here are saved into an object which is called annotation, which is not, it is only a dictionary, and this dictionary just map this to this and this to this and the return to this. This is coming from the PEP. Let me read to you. Function annotation, both for parameters and return value, are completely optional. So these new things, it's completely optional. It like you still, if you don't want to use this thing, you also normal way to use Python at this time, and you're fine. And function annotation are nothing more than a way of associating arbitrary Python expression with various parts of a function at compile time. So this is not yet about type hint. This is about associating something with the function signature. And actually, look at this. This is actually valid function annotation. So here you said what I'm doing here. Python is not a type language. Why do I even exist? And here you return another string. And this is valid. This is valid Python code. This one is valid Python code. So to emphasize, so this PEP has been the first type hint related things. But it was still not officially no type hint in Python. So at this time, Python was no reference of type of type hint when you're doing your code. But it's still an annotation which allow you if you want to do something similar, but it's not like officially in the language. And then you have to wait 8 years. And a second Python PEP arrived, and it's actually the type hint introduced in Python. It's a 10 years long history. So the guy behind Python actually coined the idea, this modern type hint that we are using. He coined it in 2014, and you have to wait 10 years for it to appear in the programming language. But the idea are quite simple. Is this is basically what maybe you are used today, nowadays in 2023. That you have all of this optional, this union, any, and you actually, instead of having a string like in the annotation, you actually put something which actually represents a type, and is coming from this typing library, which is built in the standard library. And this is actually the beginning of typing. And this typing is this typing package in the standard library. It comes with a lot of powerful typing tools like typevar, generic, overloading, covariance, contravariance, forward reference. So it's like it gives a lot of tools to Python developer to build around type hint, and it give a typing system kind of to the Python programming language. And since 2014, we have seen 16 typing related pair in 6 years. And actually, like if actually in the for example Python 12 or Python 3.11, you will see that a lot more typing related PEPs are adding to the language. So it means that Python is adopting this new technology as really fast. So let's sum up what we said in this section. So Python is not a statically typed programming language. It's a duck typing one. But type hint slowly entered the Python world. It took almost 10 years of incubation before they actually put it into the language. And this shows you how much this was a kind of a jailbreaker, because it was so kind of different of these duck typing ideas that they take a lot of time to actually make it good, to make it into the language. But since the first time it has been added, and this adding type hints, the new typing related feature in the Python language are coming at an exponential rate, and it's getting a lot of attention from the Python developer and the people who are using Python every day in their life. So let's take a look now at the type hint ecosystem, because there is an entire ecosystem in the Python world which actually use this new tool that has been added to the language to build powerful abstraction and make application and web development faster. The first one that I want to present is mypy. So mypy is a static type checker for Python, and what it's doing is it's taking a Python code base which is annotated with type hints, and it will check that it's actually correct. It means that if you define a function which suppose to take 2 ints and another part in your code base, you call this function on 2 string, it will say, hey, it's not going to work. He will just tell you, you don't have to run the code. It will just analyze all of your code for you, and it will check this will not work. Warning, this will not work. And then it's up to you if you want to fix it, if you want to ignore it, if you want to rely on duck typing and mean, I want this to fail at runtime, or if you want to check it beforehand. And this is tool mypy. It actually been here even before typing were in the language. They were having their own custom annotation, syntax, and all. But it's basically a really powerful tool, and especially if you're doing something like machine learning or web development, when you don't necessarily need to rerun all of your code each time, because it takes some time, and you want to catch small error and small bug. And then this tool is perfect because it's doing this static, well, it's not perfect, but it's doing, it's actually giving you a lot of, it's really helpful, and it reduces the time of development. Another one which is a bit more recent is called beartype. Beartype, what it's doing is a runtime type checker. So this is kind of different from mypy. mypy is taking, it's checking the type before you run your code. Runtime is at beartype will check the type of your function at runtime. It means that if you say with beartype that you have a function which takes an int, and that somehow in your code base at runtime a string is passed, it will stop working. And usually you don't want this to happen in Python, because you will rather it to try with a string to see if it's not going to work, because maybe your function, other function is inside your function will not care if it's an int to string. or a more complex class. But it's actually super powerful if you want to have a nice error message. So let's say you have some complex abstraction, and you have a function which takes a complex object, a complex class that you have created. And you know for sure that if you pass something else, it will fail. And you just want to tell the user, you only you have to pass this you have to pass this class, otherwise I cannot deal with it. Then beartype will just throw a nice error message each time the user is misusing or passing a wrong type to your function. And this is actually super powerful to have nice error message and debug message in your function. Pydantic is kind of the one of the most known Python package in this modern type hint era. But what Pydantic does, it's data validation using Python type hints. What does that mean? Let's take an example. So in Pydantic, we have this concept of base model, which is basically kind of, the way I see it at least, maybe it's not the right way, but it's like a struct in a more statically typed language. And so basically you define a mapping from a key name, like an attribute name in your Python object to a type. And it's not only a type hint here. Actually, Pydantic what it will do, it will validate that the data you pass to your class will actually respect those things. It means that here you want to int. If you pass a string for ID in the init function, it will say, no, I want to int validation error. It will throw a validation error. And and it's super powerful. Pydantic is super powerful, especially when you're doing, for example, web development. Like you want your application, like you want to expose an API and you want to say, I expect a date, a name, and a number. And if the user sends you a JSON file with something which is not wrong, you want to catch it, right? You don't want to pass it to the rest of your application, or otherwise your application might crash in an unexpected way. And well, you don't want your application to crash, right? You want to catch this error super early so that your application is always live. And this is what Pydantic is doing. So it's a parsing and validation library which has get a lot of success. And actually the guy behind Pydantic, he just started his company, just to tell you how serious this tool is getting. Another tool, probably you all know about it, FastAPI. So FastAPI is kind of the one of the latest and newest Python web framework. It's a modern, fast web framework for building API. And it's based on standard Python type hints. And it's also based on Pydantic. It's actually using Pydantic to do the validation. And it's super popular. It's super popular. Let's take at how our FastAPI application look like and how it's actually using type hints to make development of application faster and API faster. So you're relying on base model of Pydantic. So you define a class. Which will do validation for you. And then in your API, you just have to write a function which says that you expect an item, and you return a dictionary. And what FastAPI is going to do, it is going to check what you expect here. And then it will auto-generate a lot of useful feature that otherwise, like let's call it boilerplate code, that otherwise you will have to do it manually. It will generate open API specification, because if you know this, then you know you can directly map the open API specification without actually running a script for you, or actually write it by hand. Oh, this is super. I mean, you reduce the time of developing. It can generate OpenAI specification, Swagger documentation. So you just have to define your type here, and FastAPI leverage everything for you. And without this type hints, then you will have anyway when you build a web application. This information need to be somewhere. I mean, you need to say what your web API is expecting as input, right? It's not like duck typing inside Python world, but when you go out of Python world, then an API need to have an interface which is concrete. Otherwise, how can your user build upon, right? Actually, so this Pydantic and this FastAPI, they are leveraging this built-in native tool in Python to actually make this a super simple process. And let's take a look at FastAPI success. So this is the number of stars, or I know stars is not the best proxy to look at the success of an open source tool, but it's still saying something, right? And right, it's FastAPI blue is Flask. Flask was one of probably the most used web framework before FastAPI arrived, and you can see that in Fast is like I think 12 or 14 years old or something. FastAPI is 5 years old, and now it's almost the same popularity. So in a few years, FastAPI has become super, super used. And actually, it's called FastAPI, but it's not revolutionarily fast, right? It's not like 10 times faster than Flask. But what is actually fast is the fast development. And this is because it's relying on Pydantic and on type hints. Another one, SQLModel, it's actually created by the same guy as FastAPI. It allows it's an ORS or vector database which rely on type hint as well. This one as well, Typer, is kind of the FastAPI for CLI. You defined your CLI by defining the Python type hint, and then the CLI is auto-generated. So I said that I was going to do the ecosystem from web development to machine learning, the ecosystem. So what about, is there ML framework which actually relying on this type hint idea? There are some. For example, this is JAX typing. It's actually a bit unknown. It's not really popular. It's new as well, like maybe 1 year or something. What it's doing is doing type annotation and real-time checking of shape and D types of array, both for NumPy, PyTorch, or JAX. And what it means in practice is like, let's say you have an application which working on array or tensor or like a numerical data, and you want, let's say, to define this function which is doing matrix multiplication. And in matrix multiplication, for it to work, you need the shape to kind of have a correspondence. You need the y here. So the last dimension of the first matrix and the first dimension of the second matrix to be the same. Otherwise, it's not going to work. And what is JAX typing giving you is the tool to express the shape inside the typing system. And it's super powerful because then you can actually say, oh, I want something X, Y, Y, Z, and it return X, Z in terms of shape. And this is super powerful because, well, it's the same. It allows you to catch bug, like, oh, you want X, Y, but I give you X, Y, Z, like something which is too big, an array matrix which is too big. Then you know it's going to fail. And these tools help you to type hint all of this NumPy and PyTorch code base, which is usually not relying this. But it's kind of the only Python tools in the machine learning ecosystem which kind of relying on these type hints. And here we go. So and this leads us to the next and last part of the talk. So let's sum up. The Python type ecosystem is growing, and it's growing super fast. Type-based library, they are overthrowing long-standing library like FastAPI over Flask. It's only because it's based on type hint, and it's super fast how it like becomes a de facto first web framework now. But the ML ecosystem is still missing some library which are using this principle. And here arrives DocArray. DocArray is basically promised to bring this type hint for the machine learning world. DocArray is an open source library. I'll talk a bit right after, but yeah, spoiler alert, I'm one of the main contributor and creator of DocArray, and that's why I'm talking about this today. So the web development ecosystem has been completely reshaped with these type hints and the success of tools like Pydantic, FastAPI, and SQLModel. And now those three tools, for example, they are the de facto Python web stack to build a web application. But tomorrow, web application will change drastically. Because of AI, because of machine learning, AI enters the battle. So just in 2022, ChatGPT, Stable Diffusion, Whisper, music language model, all of this allow you to, instead of working only on text and on JSON object, it will take image as input, text as input, return image, return video, take video as input, return. You have all of this translation of different multimodal data. For example, just yesterday, GPT-4 has been announced. What is GPT-4? Let's say it's a big language model, but let's say it as a black box. As a web developer, if you see it as a black box, you send image and text, and it gives you text. But you see that we go into a new paradigm. You don't say you don't send date time anymore. You send image. You don't send like the data on which we operate on the new web application. It's changed slightly with this AI, and this will have a big impact, especially in the tech world and the way we will build application. This for sure will be a revolution. So this new application requires manipulating what we call multi-modal data: image, audio, video, 3D object, multimodal data. The same way us as human, we can have different modalities, different sense. I have my vision, my hear, like we work on different modalities, and those AI as well will work on different modalities. But if you look at Pydantic has predefined types in Pydantic. For example, that time, URL, even have a payment card inside Pydantic. Is to show you how much it's focused on this, let's call it classic web development. All of the data types are JSON friendly and it's string based. Usually you send string basing. But this changed completely with AI, with with GPT-4 coming yesterday. Like basically the web application world will be completely reshaped. And here enter DocArray. DocArray is a library for representing, sending, and storing multimodal data. So audio, image, video, etc. It has a focus on application on machine learning, generative AI, and neural search. It's built upon the tools that I told you before, especially it's built on top of Pydantic. It's kind of, I like to sell DocArray as a Pydantic with a hint of machine learning. It's compatible with FastAPI and most of this type-hint ecosystem. It's Python. It's already 1 year old and get quite some success in the machine learning world and in the web development world already. Just to give you some information about the project, who we are behind this. It's a project that's just moved into the Linux Foundation AI and Data 3 months ago. Right now, as we are talking, we are into a really heavy development. We are actually rewriting the project from scratch. And as of today, we are 6 people working on this full-time, backed by our company, Jina AI, and a community of more than 100 developers helping us in an open source way to build this tool. DocArray is a multimodal ML library, so this is all of the type on which DocArray can work, and we even want to extend it to more modalities in the future, and basically do the bridge between the different modalities and the different compute and the different storage. Let's take a look at how it looks like in practice. So let's say you want to build a web application which take as input a podcast and can basically look inside the podcast. And let's say the user want to look inside the podcast for a special moment. Like he say, I want to search in this podcast the moment where the speaker will say this sentence. So as input, you will have a podcast and the prompt that he has been asking for, right? And your application will be based by the AI, a large language model, which will be able to look into the podcast and find the relevant moment, and it will return you the exact moment when this speaker actually say this sentence. And how you with DocArray, let's see how we can actually how it will actually look. So you will create a podcast. Let's say that you wanted to have an image, a banner kind of, and an audio. The audio is actually the most important part. So you first define this image class, which is just an image URL or a byte or a bytes, like actually image file. Same for audio. And in your podcast, you have a description. Well, description of the podcast is just a string. Title of the podcast is just a string. Then you have the audio of the podcast. This is an audio object. This is an audio document. You have a caption, a banner if you want, the small icon when you are on Spotify. This is an image. And you have the embedding. Embedding is like a representation in terms of vector of the podcast. And you can see that this really looks like FastAPI, Pydantic, sorry. We have this base document instead of the base model from Pydantic, but it's actually, this base document is a base model from Pydantic. It's built on top with some machine learning feature and multimodal feature, but in the essence, it's still a base model. And all of these type are actually nothing else that advanced type, which allow you to load, manipulate this multimodal data in a seamless way, in a kind of similar API for all of the modalities. So you don't have to, like, for new modalities that you add to your project, you don't have to like learn a new library. You use the same. It's like load. It's like show. It's always the same way of working. You don't have to learn a new system. And you treat modalities as you can scale the number of modalities. It's the same code basically. It's array first. So DocArray, as its name said, it's actually one of the big things is document array. Document array kind of extend the concept of base model, of base document, of Pydantic into an array. It means that it's a kind of a column-based data structure. And it's actually in machine learning, you usually want to work in an array mode because those big models, they need to process data in chunk, in batch to be efficient. Another thing, and it's DocArray. The same way in the FastAPI world, you have this SQLModel, which allow you to be an ORM for SQL database. We are ORM for vector database. And maybe you don't know about vector database, but those vector database are the database of the AI world. And they can store basically what we call embedding. Embedding is just a vector representation of any data. And you can retrieve this embedding. So you can do some nearest neighbor search between two embedding to see if two objects, two multimodal data are close to each other. And you can do things like neural search and things like this. And we have a lot of different vector database right now. Probably some of them will disappear at some time, and probably one of them will become the industry standard. But as of right now, we don't know. And DocArray try to build a seamless integration with all of them, and it's really an ORM for vector database, which kind of integrate all of them at the same time. DocArray is living into another ecosystem, which is around Jina. So Jina AI is a company for which I'm working for. We're actually trying to build the entire ecosystem for this multimodal AI. We have DocArray, which kind of Pydantic for machine learning. We have Jina, which is a FastAPI for AI application and machine learning. Especially we rely on a gRPC. We have a lot of cloud solution. And DocArray, again, is kind of the SQLModel for a vector database. So 3 years ago or 4 years ago, the tech stack was this manual validation, Flask, and SQL Alchemy. And then, boom, type hint arrived in the Python language. Well, not exactly 3 years ago, but people start to like type hint. And Pydantic FastAPI SQLModel has become really fast, really fast, the de facto way to work with the Python world. And we hope that with the, and we strongly believe that the AI wave which is coming, this multimodal AI wave which is coming, it will impact so much the Python ecosystem. And we hope that we try to build the best tool to adapt to this wave of AI coming into the web development. About Jina, this is a company we are distributed into 4 offices on 3 continents. We are 3 years old. Yes. Okay. I'm almost done with my talk, but let's sum up what I said during almost 40 minutes now. Type hint are entering the Python code base. Like this is a fact. From the PEP in Python to the usage of the tool around type system, around like FastAPI and Pydantic, it's like there is definitely a modern way of using Python. I'm not saying it's the best way. I'm not saying it does not have any flow. It has actually a lot of problem as well. But this is a new way of working, and it's accelerating development for sure. And this type hint ecosystem is growing fast, and it's eating up the Python world. And DocArray, this library that we are trying to create, and it's a good track is it's try to embrace all of this type hint wave and try to apply it to the ML AI world and to adapt to what is coming. Maybe you can say it's coming today. I mean, GPT-4 out yesterday. Something will happen. Even in the next weeks, you will see the face of the web application will already change. And I don't even imagine how it will be in 2 years. But for sure, all of this tool will be part of our tech stack. And we hope that we are building the tool to give developer good abstraction and to make them developing AI application faster. I'm done with my talk. Feel free to follow me on Twitter or to take a look at DocArray on GitHub. And we have as well a Discord channel when we are doing a lot of active development with the community. As I said, we're in complete rewrite of the library. It should be released in couple of weeks. And yeah, I think it's super interesting if you want to be active in an open source community to join us on the Discord.